So you'll be doing quite a few different searches in your post lab for experiment 6 using the webCSD. So we're going to look at what a substructure search is. And so we're going to do a substructure search on acetylsalicylic acid. And then we're going to look at a substructure search involving a transition metal. So here I've chosen salicylic acid and copper. We're going to search that, show you how to do that, what a simple search is, and then we're going to look at exact searches. What's the difference between a substructure and an exact search? And we're going to do an exact search on the different types of drug compounds such as ibuprofen, naproxen, and phenacetin. And then we're going to look up a ref code search. So we're going to show you how to do all these different types of searches using the webCSD. So now again, you go to the webCSD through my UTSA and library databases. So when you get to the webCSD database, and again, it's from chemistry. So you go to library databases, chemistry is the second hit. You click on it. It'll ask you to log in. And then you log in. It's going to bring you to simple search. Oh, and I have to log in again. Yes, it's the web Cambridge Structured Database. Yeah, so you click on Cambridge Structured Database. That's what we refer to as the web version of the Cambridge Structured Database. So it's going to bring you to simple search. So there's one simple search you're going to do, and that's with caffeine. And so what you do is under compound name, we'll do simple search first. Under compound name, you just type in caffeine. And what's it going to do is it's going to search the entire database for any crystal structure with caffeine in it. And so you click search, and make sure you spell it correctly, because if it's not spelled correctly, of course, either you won't get any hits, or you'll get the wrong hits. And so when you do a simple search with caffeine, you have to go through and look. So it has a little picture of the structure. And so with the simple search, it's a little bit tedious, but this is the most efficient way to find the structure. So you'll see here there's a little picture. What you're looking for is a picture of just showing you caffeine. So if you see two molecules in it, that's not what we want. So we just want to see the crystal structures with only caffeine in it. And so you would scroll down and look quickly, identifying. So this one, still not, because it has water. You look until we see just caffeine. So you're going to scroll through. We still see it with water. Scroll, scroll. And it has to be just what we want. So we're looking for just caffeine. So this is the quick way. You just scroll through until you find caffeine. Hopefully we can find it. So, and they're all in alphabetical order, by the way. Let's see, caffeine. Where are you, caffeine? So you're just looking through scrolling through the pictures to try to find the only one that contains caffeine. And it's there somewhere. Here we go. See? So now we finally got to the end. You see, this is the structure of only caffeine. And there's multiple ones. I'll go back and check. But these are the ones that just contain caffeine. So you'd have to scroll through, and there might be more on the next page. You scroll through, and they'll ask you questions. For example, which one of these is the earliest crystal structure? So what you would do is if you click on what's called this ref code, you click on it, it'll tell you information about the crystal structure. And what you're looking for is the publication date. So here, this one, the article was published in 2005. So if you were looking for the earliest crystal structure, you would see the one with the earliest publication date. Now let me go back to search. Someone mentioned, let me see. And so you may or may not get caffeine. It just depends on the question. Some may get it, some may not. No, so someone had mentioned it as CINZEF. Well, this has mercury in it. So we're just looking for the ones with only caffeine. So if it has any other element attached to it or anything else in the crystal structure, that's not what we're looking for. We're just looking for specifically only caffeine in the picture. You're welcome. So this is caffeine. If you were to get this question, this is how you do the simple search. You just simply type the compound name, and you quickly scroll through, look at the pictures, and you're looking for the picture that only has the caffeine in it. If it has anything else attached to it or anything else in the crystal structure, it doesn't count. And then you click on what's called the ref code. That'll direct you to that particular structure. You will be able to click on the article if we have access to it in the database for UTSA, and then you'll be able to research the article. So mainly when you're reading the article, we mainly want you to read, and we'll look at one in a little bit, you mainly want to read the abstract, introduction, and experimental. So that's mainly where we're going to ask the questions from the article. So abstract gives you a brief overview of the paper, the highlights. Introduction gives you the background, and experimental explains how they perform the experiments. So that's a simple search. Now we're going to go to a substructure search. So simple search, very easy. You just type in the compound name, do a search, scroll until you find what you're looking for. Now, one of the compounds you may have to do a substructure search for is acetylsalicylic acid, and so you have to make sure you draw this correctly. So now what you want to do is you want to click on the one that says add phenyl ring if we're drawing acetylsalicylic acid. It's a 6-membered ring with the lines inside. It's called a phenyl ring. And now we're going to go to carbon, and we're going to add some bonds. And so let me just draw what acetylsalicylic acid looks like so you can see what I'm drawing. And you want to make sure to include all the hydrogens on the atom. So that's our phenyl ring. Then we have this carboxylate group. That. So that's what I'm drawing in this structure. All right. So now we need it's okay, it's all carbons now. We'll show you how we fix that in just a second. So what I'm doing is I'm just clicking and dragging and adding. So now we have the double bond, the single bond. We want to change these to oxygens. So notice how this one put a OH on it. So if it does this, this is not correct. So we're going to erase it. And we're going to click oxygen and select double bonds and then drag. And now when we put the oxygen, it has it. Yeah, the lines should join between the carbon and the double bonded oxygen. So let me go back and redo that again. So let me erase. So we want to do a double bond. You just click it on this carbon, you click and drag. Then you select oxygen, you put it at the tip of that double bond. So it looks like this. And then we want to draw this component. So here, this should be an oxygen where it says CH2. So we're just simply going to click on oxygen. See how the green square comes up? We click on it, it replaces it with an oxygen. So notice that this CH2, we need a double bond again. So I want to select double bonds, click and drag. So again, when you get the green square, that means you're good to drag. See how the green square around the CH2, you click, you drag, and now we put a oxygen. And then we do the same for hydrogen. It's a single bond around these. So we just add single bonds, then we're going to put hydrogen on the tips. And so this is what your acetyl salicylic acid should look like. So here's what we, so now we're ready to search. So one thing about the search is when you do this search, you want to make sure for this one, acetyl salicylic acid, it's on substructure search. So the default is exact, but you want to make sure it has the substructure search. So then you go to search, and if you did it right, it's going to give you the hits that contain that acetyl salicylic acid. And it's searching, and it found 82 results. So here what you would have to do is substructure, you just have to go through and just to let you know that ACSALA is for acetyl salicylic acid. And so you just have to go and scroll through and see which one of these is the earliest crystal structure, or it may ask you, you know, which one was, you know, ACSALA 19. You may look it up, but these are the ref codes for acetyl salicylic acid. And then you can scroll through and see if there's any additional ones just by quickly going and clicking on the other ref codes. So here this one says aspirin, but it's a little bit different than the structure. So the structure highlighted in orange is what we've drawn. Whatever else is in black. So we only want what has orange in the structure. And this is how you perform a substructure search for acetyl salicylic acid. And it's just since we're next, we're going to look at salicylic acid and salicylic acid with copper. So let me show you the structure of salicylic acid. And so you'll do the same thing with acetyl salicylic acid, except that I'm using copper or salicylic acid just as an illustration. So whenever you're looking for a metal complex with your compound, you want to leave the hydrogen off the alcohol group. And so that's on the carboxylate group. You want to leave the hydrogen off of it. And the reason is because when a metal coordinates, it coordinates with a single bond oxygen that doesn't have a hydrogen on it. So now there's going to be a coordination between the copper and the oxygen. So what we want to do here is we want to draw salicylic acid. And it should look something like this. So notice on the carboxylate group, there's no hydrogen on the oxygen. But let me just draw it from scratch so you can see everything. So the reason I did this is so now when you see it's CH3, when you go click on the oxygen, it'll put an OH. So here this shows an OH. So we want to get rid of that hydrogen on that oxygen. So again, single bond. And this is how you want to draw your compound when you're looking for a transition metal with a particular transition metal, because the OH group on the carboxylate group, carboxylic group, we needed no hydrogen on it. And then all you do is you come down here to where it says element chooser, and you select your transition metal that you need to research. So this one we're going to do copper, and you just put copper somewhere in the structure. Again, you don't connect the copper to the molecule. It's just like this. So again, if this was acetylsalicylic acid, the OH attached on the carboxylic group would have no hydrogen, and you would put your transition metal floating out here, not connected to the oxygen. And then make sure it says Substructure Search, and you hit start. And so some questions may come up, like, for example, how many structures are there of just copper and for example, salicylic acid, or copper and acetylsalicylic acid? So you'd have to scroll through and see which ones contain just copper and acetylsalicylic acid. So one thing to bear in mind is if you see a identifier and below it you see the exact same identifier with a number, they're going to be the same structure. So if you know that ASA-LCU is not what you're looking for, then you can skip all the ACA-LCU ones, and then you can just go to this one. So again, if you see the same identifier, but the only thing different is a number, that tells you that it's the same structure, and you can skip it if you don't need it. So it kind of help you scroll faster through the list. So again, the question would ask maybe, how many just contain copper and acetylsalicylic acid. So you'd have to scroll through and see which one, like for example, this one, copper and acetylsalicylic acid. And you see copper has 4 ligands around it. So this is how you would research with a transition metal complex. Look at one more. So for the other types of molecules that you'll be researching, such as ibuprofen, naproxen, or phenacetin, you're going to do an exact structure search. And this is to help minimize the number of hits that you get. So with an exact structure search, again, you got to draw the molecule correctly. If the molecule is not drawn exactly as shown in this video, it won't give you the correct hits, or won't give you any hits. 99% of the time when someone says they can't find something is because they haven't drawn the molecule correctly. So I'm going to draw ibuprofen, and we'll do an exact structure search of that. And so if you remember the structure, it looks something like this. And I'm no artist, but best I could do. Looks something like that. So we want to put carbon. So you just click and drag. Click and drag. So that's this end. Now we want to do the other end. Switch this to a double bond. Put in our oxygens. Now we got to add our hydrogens. So this is what ibuprofen looks like. So again, we want to do an exact search. So you make sure exact is selected. And then we're going to hit search. And so there were 46 results. Again, for example, Cotyo, C-O-T-Y-O-A, is the, it shows a ref code, but you don't see ibuprofen by itself. So you just have to scroll through until you find the structure with ibuprofen. Now, let's say you find one that you like. If you scroll down, if you click on the associated publication link, it'll direct you to the article. And again, you don't have to purchase these articles. They're all, if it's available, it'll be available to download. So now this is one, of course, the one I picked is not one that you can download. So let me find another one. Can't pick that one. Here we go. So again, when you're reading an article, you should read the abstract, the introduction, and then typically there's an experimental here. So this would be the experimental part. And that's pretty much all you need to read about the article, because if any questions are asked, it's typically going to come from the abstract, introduction, or the experimental section. So again, that's how you do an exact search, and you're looking for exactly ibuprofen. So you would scroll through, find the article that the question is asking for, read the article, and answer any questions. Now, sometimes it may ask about a space group. So if you scroll down where it says crystal details, it tells you about the space group, unit cell, etc. for the structure. So that's where you get that. Again, the publication date is the date of when the article was published. That's what you're looking for. And that's how you do an exact search. And one last thing, just to show you how to do a ref code search. So ref code is an identifier. It's an alphanumeric identifier. And that takes you directly to a structure based on that identifier. And so you may be given a question that says, look up this structure with this ref code. So all you do is you come to identifiers, you type in the ref code, and you hit search. And it'll bring up the particular structure that you need. And then all you do is you read down here the information, you click on the article as well. So when you're given a ref code, it's pretty straightforward how to search for it. You just go to simple search, type in the ref code under identifier, and then it brings up that particular structure. So those are the different ways you maybe ask questions for this post-lab experiment.